Annie Snabes, thanks for joining us on the Illinois Channel. You are a graduate student at the Medill School of Journalism, and that, of course, is part of Northwestern University. And unlike a lot of people, you are very interested in the sciences, and you're bringing us a story that we will have on our website, illinoischannel.org. You're bringing us a story of a breakthrough in how to make some new viral drugs. It's somewhat complicated. So tell us the big picture. What's the story and why does this matter?
Well, thank you for having me on the Illinois channel. And my article is all about research done by Michael Jewett's lab at Northwestern. And I guess the overview of the research is that they're working with this kind of biotechnology called cell-free protein synthesis. And essentially, often when antiviral drugs are being made, and these are the kind of drugs that can treat viruses, these drugs are often made inside cells. But Michael Jewett's lab has found a way to potentially make antiviral drugs outside of cells. That's why it's called cell-free protein synthesis. And it's really important and unique because this process of making an antiviral drug outside of a cell in a test tube or something like that is significantly faster than working in cells.
When we say that it's significantly faster, that's on one hand very good news, especially as we race towards a cure for things like coronavirus. How much faster would this be? So, and let me back up. Did you say it's a protein made outside the cell rather than inside the cell? Is that right?
Yeah, and it often is protein. Sometimes it might not be a protein, but it might be some other similar kind of molecule. But yes, these molecules are in this technique. They're made outside the cell.
And how much faster does this technique cut off the development of these antiviral drugs?
Good question. Well, when researchers are generally making proteins inside cells to be used as an antiviral drug, that process can take weeks or even months. And this faster technique allows you to develop an antiviral drug in a matter of days. Sometimes it could be longer, potentially. I'm not, I'm not sure about the exact time period, but it's usually days. It's significantly faster.
And while we are all focused on the coronavirus, the fact of the matter is this is not tied specifically to that. It may help with that, but it would help in any number of new drug developments. And just as corona kind of came out of nowhere, we always, the human race is always subject to some new, and just as we call this a coronavirus, a novel coronavirus, we're always subject to the possibility of having another novel virus come out of wherever to threaten the world health, right? So to that end, I imagine this is a major breakthrough. How did you happen to hear about it to write your article?
Good question. Well, I found out about it. I was reading press releases from Northwestern because I was interested in, I have a biology background, and so I was interested in writing about some kind of advancement going on right now that has to do with biology in one way or another. And actually, there's one other thing I wanted to add. So Michael Jewett, one thing he said to me that really stands out is he thinks that this could advance the discovery process of finding antiviral drugs. So this technique is very fast. It allows you to make an antiviral drug or some kind of molecule that could be used as an antiviral drug very quickly. And so that could help scientists discover these drugs more quickly. And then after that, once they kind of have found something that they think would be great, it still would have to be tested on people to make sure it actually is an effective drug.
Did you talk to, is it Jewett, Professor Jewett? Did I say that right?
Yeah.
Is he involved in the search for a cure to the coronavirus?
That's a good question. I think he also works with he's also involved in a startup, and I think that startup is doing work trying to find an antiviral drug. And so I think he is involved in this effort. And in fact, a lot of his lab's operations are currently not going on right now. But the reason why some of their researchers can continue doing work right now is because basically, well, to give a bit of background, a lot of research labs are currently not doing research right now because universities they want to be safe, and they want to make sure that the people who are doing research are doing it on coronavirus because it's an essential task right now. And so his lab decided to pivot some of their research work to focus on coronavirus. And so this research they're doing on trying to develop antiviral drugs quickly, that is something that could potentially be used to find an antiviral drug for COVID-19. We don't know for sure if they're going to be able to find one, but I think this technique is a fast way of finding antiviral drugs, so it could be useful in the future potentially.
Well, that's all good news because obviously, when we look at the pandemic back of 1918 with the flu, I hear differing numbers on that, but it's somewhere between 25 and 50 million people were killed in the 1918 pandemic with that. I forget if it was the Asian flu, but the United States actually lost more men in our army from the flu back in 1918 than we lost in World War I in combat. And again, now we're in the midst of another pandemic and hopefully coming out of it. Was Mr. Jewett, Professor Jewett, when you talked to him, how would you assess how excited he was that they now had this new technique? Just again, to try to put it in the context of how big is the news, how big of a breakthrough is this?
Yeah. Well, I guess I think he is very excited about his work. But I guess I'll also say that it's not completely new. This is their work on cell-free protein synthesis systems. There have been other labs who have worked with cell-free systems in one way, but I guess in terms of his lab's own work with cell-free protein synthesis systems, this is actually something they worked on before the coronavirus, and we're kind of able to adapt it for this new problem in our world. But to backtrack a little bit, their lab in the past has also used this technique to work on ways of detecting contaminants in water. They've also used it for another purpose, which I forgot. But basically, that you can use this technique for other purposes, and they were able to kind of use it for this newer, world problem as well, which is really fascinating. And I think to go to your point about excitement, yeah, I think it is something that they're excited about. And I did also talk to a researcher at Cornell, and she says that there are definitely advantages of cell-free protein synthesis. One of which is just that it's faster, as I said, and also you kind of are not restricted. There's cells, working a cell can have restrictions. And like, for example, sometimes you might have to make sure the cell is at a certain temperature. But if you're not working a cell, you don't have to worry about those kind of inhibitions. You can just do it outside of a cell, and it's easier.
We are blessed in the United States to have the healthcare system we have, but when we look around the globe, many third world countries, they may be far more impacted by various viral diseases that we are no longer. Is that the case, number one? Because it's really a question. I don't know that necessarily to be true. And I guess what I'm getting at is, to what extent would this new approach to developing the viral drugs perhaps be far more advantageous to the populations of the third world countries than perhaps in countries like the United States, where we have a viable healthcare system?
That's a good question. Yeah, I think I guess this isn't my expertise, but I'm sure that if this technique was used to help find an antiviral drug for COVID-19 or a similar virus, that it could be really helpful in those countries, especially it could be used. I mean, I feel like with our healthcare system in the U.S., even though it's true that, well, actually there is remdesivir is an antiviral drug that's starting to be used for COVID-19. So we do have something, but I think in the U.S. just I think there's more potential. I think to help anyone be cured of this disease, whether it's in the U.S. or in a developing country, if we have more antiviral drugs.
Before we close out, Annie, when I think of Northwestern, I think of a number of different academic disciplines. I certainly think of journalism and the Medill School of Journalism there, which the Illinois Channel has worked with for a number of years. How much is Northwestern actually involved in medical research like this, which kind of caught me unaware that they were that involved to have such a breakthrough?
Yeah, that's a good question. There are several labs. While I was kind of looking for a story to write about this, I read about different research going on. There is, I forget her name, but there's one researcher who is working with some other researchers on, I think, really learning a lot about the structure of this coronavirus virus, and looking at like the RNA code and just trying to really get to know it well. And there's other researchers doing other things. I think some are kind of looking at coronavirus from more of an engineering perspective. And Michael Jewett's actually a biological and chemical engineer. So you really can look at it from different perspectives. And there are several Northwestern labs who are trying to use their own expertise to try to help with this pandemic in some way.
Well, we appreciate you bringing this story to us. I've not seen this reported elsewhere. Probably a lot of our readers will find the same thing. It is a text article, but we'll have now your interview to help us go through it when we're reading it and have a better understanding. And we appreciate you joining us on the Illinois Channel. When before we close out, when are you actually graduating, and what do you hope to do in your career?
Oh, good question. I'm graduating on June 19th virtually. There's going to be an online commencement for Northwestern. So I'm excited for that. And then for my career, well, after I finish my graduation, I'll be interning this summer at the Indianapolis Star. So I'm excited for that opportunity. And then in the future, I have several different interests. I am very interested in science and health reporting, as you can tell through this story. But I also am interested in other issues like housing and politics and just a variety of things. So I'm kind of both interested in general science reporting and science reporting, and hopefully can find some combination of the two.
Well, Annie Snabes, we appreciate you bringing this article to us. Good luck to you. As I have told the people at the Medill School of Journalism, I've never had a clunker when I've worked with a student. They're all very bright young people. You're certainly one of those, and best of luck to you in your career.
Thank you.
Thanks for watching, and if you haven't already, please consider subscribing to our channel. And while you're at it, please leave us a comment. Thank you for watching.